Hello everyone. So we are here again. This is the part 2 of our recording. In this part, as we said, we are going to test all the features that we have one by one. So I have this account. So let me just do login to my own account at flaplet.org. So after login, you will see this dashboard, which is an overview of all the tasks that you have. For instance, now I have one completed datasets. I have two completed machine learning sessions, two completed graph generation tasks, and one completed data augmentation task. I have sent two bug reports to the admin. I have sent my feedback to the admin one time, and I also have one message from the admin. For instance, here, if you click on this, go to messages, you will see the messages that you have received from the admin of the project. And you have the profile information page. You can see your information here. You can change your information if you click on this button. And we have feedback page. You can send your feedback to the admin. You can give us a score, and we also have bug report. You can take a screenshot of the bug that you have seen or any issues that you have encountered, and you can upload the picture to us, the picture of the bug or the screenshot of the bug, and you can also write some description for us and choose the type of bug that you have encountered and send it to us so that we can work on it to fix the issue. And we also have layout. And here we have the dashboard. As you can see, you can close this menu if you want more space here. And we have these four tasks: uploaded datasets, data augmentation, graph generation, and machine learning. So we will just click on this. I uploaded a dataset a couple days ago. Now I'm gonna upload another dataset. So I will just click on this new dataset button here. I will just write first large dataset. This is the name of my dataset, and I will just write a description. This is just a test. For instance, I am uploading a large Swan SF dataset. So these datasets that I have created, which are large, medium, and small, are based on Swan SF dataset, which is a very popular dataset, time series based dataset for solar flare prediction. So you can choose the type of missing value technique that you want to perform on the dataset. So now I'm gonna just click remove all the missing values. You can also perform mean imputation on them. And you can also choose a normalization technique. We have min max scaling and z normalization, and also nothing if you want to just do not any normalization. I'm gonna select z-score, and I'm gonna click on this to just upload my dataset. I have mid and large. So we have two different files. Both of them should be pickle format, and one of them is just data. The other one is the label of each sample. So I'm going to upload this, and then I'm going to upload the labels here, and then click on this reCAPTCHA from Google, and then click on upload. So now here we have a list of our tasks. This one is completed, which I created a couple of days ago, and this one is running, which is the task that I just created. If I just refresh the page, it's completed. So here you can see all the metadata tags. For instance, we performed, this was the name of it, this was the description of it. We performed removing missing value samples technique on it, and z-score normalization. um, and this is the result, and this is the pre-processed train file. So we have created two different files. One of them is the data, the other one is the labels, and you can download this newly pre-processed data. If you click on this download processed dataset, you can download the newly pre-processed dataset so that you can use it in your own projects. So you can use our platform as a pre-processing platform, which is free. You can upload your dataset, it will perform pre-processing on it, and then you can download the dataset to just use it in your project. This is the X train and Y train that we just downloaded. So we uploaded this dataset at this time, and it finished at this time, which took less than 1 second for our server. You can also download a full statistical report of this task. If I click on it, it will be downloaded. Let me just open this. And here you can see a summary report of our pre-processing and dataset uploading task. You can see the original shape of our dataset. We had 3000 samples, 6 features, and 60 timestamps, which is a multivariate time series data. We had 2 categories, major flaring and minor flaring. Major flaring is class X and M flares. Minor flaring, which is this, is class B, C, and FQ flares, which are very weak flares. So as you can see, it's not balanced. We have more samples. Sorry, 0 is minor flaring, BC and FQ, and 1 is X and M. As you can see, it's not balanced. We have less samples for the strong flares. And you can also see the mean and standard deviation of all the 6 features that we had. You can use this type of information. We have the correlated features. Some of our features are correlated, so I have listed all the features that have a high correlation here. And this is also a final shape. So as you can see, we have removed some of the samples. Why? Because we had missing values, and we chose to remove the missing values, as you can see here. So we just removed them. So yeah, we will see a list of all our datasets here. They are stored in PostgreSQL, so you can have these here as long as you want them, or you can click on this delete button and delete them. Now I'm going to perform a data augmentation task on my dataset, because as I showed you, it was not balanced. We didn't have the same amount of samples that we had for the minor flaring category. So I'm going to perform data augmentation on it. So I will click on this. I will go to the data augmentation page here, and I will click on this button at the bottom right corner. I will, for instance, first data augmentation. This is just a name, and this is I am performing a data augmentation on my large swan SF dataset. For instance, this is a description, and you can select the datasets that we have. So we have 2 datasets, as I showed you. This is the dataset that we just created and ran data pre-processing on it. So I will just go ahead and select this. We have 2 options at the moment. We have only SMOTE, but in the future we will also have TimeGAN for data augmentation. I will click on SMOTE, and you can select this number of neighbors as a hyperparameter. I will put it on 8 and click on this I'm not a robot and create the task. If I just refresh the page, it's completed. This is a task that we just created. You can see all the metadata that we have. We selected 8 for the number of neighbors, SMOTE. This is the dataset that we just selected. And again, you can download this augmented dataset. You can click on this. You can download the training data. We need to wait for a couple seconds to be downloaded. Yeah, it's downloaded. 12.1 megabyte, as you can see here. So you can just download, you can use our application as a data preprocessing and data augmentation platform and download the data, and then you can run your own machine learning model on the preprocessed and augmented datasets. And you can also download the statistical report of this data augmentation task. I will just open it for you. So this is the original shape that we had. This is the label distribution that we had before augmentation. This is the, after we ran the data augmentation on it, this is the final shape. As you can see, we have more samples. And as you can see, this is the label distribution after the data augmentation. As you can see now, our data set is balanced. We have the same number of samples for category 0 and 1. Category 0 is minor flaring, category 1 is major flaring, which means we have a strong flare. Before data augmentation, it was not balanced, it was imbalanced. So this was an overview of data augmentation task. You can again remove these augmented data sets and tasks that you have by clicking on this delete button, but I will keep it for now. We can also perform a graph generation on it. So we will go to the graph generation task here, and I will click on this button on the bottom right corner. I will put a name for it, graph data, for instance, graph data first. This is a graph generation task on my augmented and pre-processed data. So here you can see a list of all the datasets that we have. These two are our uploaded datasets, which we performed data preprocessing on it, and these two are our augmented datasets. So they have both data augmentation and also data preprocessing from the previous task. So we just created this first large dataset and also first data augmentation. I'm going to click on this first data augmentation because it's a dataset that we perform both preprocessing on it and also data augmentation. It's a good dataset. Here you can select some hyperparameters. Pearson correlation threshold, I'm going to put it on, for instance, this number. A maximum number of neighbors that a node can have, I'm going to put it on 12. And let's create this task. It's running. This is the task that we have. Let me just refresh the page. Yeah, it's completed. So here you can see all the metadata. We selected this for our correlation and 12 number of neighbors, and we perform it on this dataset. And this dataset was an augmented dataset with these features. So now, again, you can download this new graph dataset. You can download the graph features or the graph data, 2 megabytes. You can also download the labels of the data. So you can use the graph data in your project and research. And you can also see a report. Let me just open the report that we just downloaded. This is the original shape of our data. So we created this amount of nodes. Each sample is a node, and we have 40,000 edges based on the two hyperparameters that we have, Pearson correlation threshold and maximum number of neighbors that we chose. And this is also our label distribution. So you can also delete any of the tasks that you have. These are the tasks that I created a couple of days ago. And now let's talk about the final task that we have, which is the most important task, which is running machine learning or on graph data or augmented data or uploaded data. So I will just go to the machine learning page here, and I will click on this button, new ML session. I will select a name, for instance, GRU on augmented data. This is, I am training an GRU model on my balanced data set. So here you can see all the data sets that you have. These two are our uploaded data sets. We just uploaded this, and they also have pre-processing on it. So we also perform pre-processing on them. These two are augmented data sets, which at first they use one of these two, and then we perform data augmentation on them. And these three are our graph data. So if we select any of these four data sets, which are time series based data sets, we will see GRU and SVM. If we select GRU, we will see the hyperparameters of the GRU that we can select. If we select on SVM, we will see the hyperparameters of the SVM model. But if we click any of the graph data that we have, we should be able to see this type of model that we have. So for machine learning training on graph data, we use Node2Vec plus logistic regression. If we select it, we will see the hyperparameters that we can select for this model. So now I will, for instance, select this data set that we created, which is time series data, and it has both data pre-processing and data augmentation on it. I will select the model, for instance, GRU. I can select the train test splits. So we split the data into train and test, and then we train the model on the train test, and then we perform solar flare prediction on the test set, and then we provide all the evaluation metrics that we have. For instance, I will put it on 80% train, 20% test, and learning rate, it's good for me. For optimization, we have Adam, stochastic gradient descent. I'm gonna select Adam. Number of GRU layers, I'm gonna select 4, for instance. Dropout rate, I'm gonna select 0.2. Batch size, I'm gonna select 64. Hidden size, I'm gonna select, for instance, 64. And number of epochs, I'm gonna select 10 epochs. Let's run this machine learning training on this augmented data set that we had. So this is, as you can see, it's running. Let me just refresh it. It's still running. I think it's gonna take a couple of seconds to be finished. Let me refresh it again. It's running again. So I think we need to wait for a couple of seconds. Again, at the same time that this task is running, we can go to the graph generation and see our task that to see all the tasks that we have for graph generation, for data augmentation and pre-processed data sets. We can create multiple tasks at the same time, so we can have multiple running tasks at the same time. It's not going to make any issues for our servers. As you can see, it's completed now. Here you can see all the metadata that we have. For instance, we selected GRU, 80% train test split. These are all the hyperparameters that we just selected. We performed this machine learning training on an augmented data set. This was the name of it, and it had SMOTE and 8 number of neighbors for a SMOTE and all this stuff. You can download the model. For instance, you can use the model. For instance, imagine, let's at first see the classification report of this model training. Let's click on this and see it here. As you can see, we perform tests on our test set, and here is all the information that we need. As you can see, we have achieved a TSS of 0.88, which is a significant and very good result for solar flare prediction. I think as far as I'm concerned, The best TSS that we have in 2025 is around 0.84 for a research paper. So these are very good results. So you can see TSS, HSS1, HSS2, GS, which are very popular metrics for solar flare prediction. We also have accuracy, precision, recall, and area under the curve. And we also have these four metrics. By using these four, you can calculate any evaluation metrics that you want. So yes, so imagine if the results are incredible, you can use this model that we just downloaded for real-time solar flare prediction dataset. So you can see both the report and download the model. So yeah, so astrophysics researchers, users, students can work with this web application. For instance, if they select another set of hyperparameters, they may get a worse result, a worse TSS accuracy for solar flare prediction. So this web application gives the ability to researchers and all the users to run data preprocessing, data augmentation, graph generation, and also machine learning on their datasets that they have without having the knowledge of Python and AI and TensorFlow and all these frameworks, Pandas, NumPy, and all this stuff that we need for the field of machine learning and data science. So they can just interact with this web application, which is buttons and tags and different types of HTML features, and they can easily perform pre-processing on a dataset or perform machine learning, model training on a dataset, perform data augmentation on it, and they will have access to all these features and all of their data. For instance, if I just log out and go to the home page, which this is the home page, if I go to the login and log in to my account again, I will see all of my data here. You can see all of the tasks and all the data that we have here. For instance, we just created this machine learning training task where we have access to it. Let me also go ahead and perform a not-to-wake task on a graph data. So I'm gonna select one of these graph data that we have. We just created this graph data. So I'm gonna select this one, and I'm gonna select not-to-wake plus logistic regression for model training, and I'm gonna put this on 70% train test split, and I'm gonna just select my own hyperparameters, for instance 64 and 12 walk length, window size 10, batch word 128, penalty L2, and solver this one, and I'm gonna select, for instance, 30 iterations. I'm gonna create this not-to-wake task. As you can see, at the moment it's running, it's gonna take almost 1 minute for it to be finished. So we can go to the dashboard that we have. You can see an overview of all the tasks that we have. For instance, for machine learning, we have 1 running task and 3 completed. This running task is the task that we just created. It's a not-to-wake task. We have 2 completed datasets. We can also see any of our failed tasks. So if any issues happen in the backend, for instance, if our dataset has some issues, if anything happens in the backend, you will see failed here. For instance, you will, instead of seeing completed or running, you will see failed. And yeah, so we are also managing all the errors that we have in the backend. So it's a very robust web application that we designed and we developed. So, oh yeah, it's completed. You can again see all the metadata tags that we have. We selected these in hyperparameters, and we perform it on a graph data. This was the name of it. So we can download this logistic regression model, which is trained. We can use it for real-time Solar prediction. It's in a pickle format, and we can also see the statistical report. Let me just open the report. As you can see, we have achieved this result. The TSS is 0.81, which is incredible because we performed this machine learning training node to wake plus logistic regression task on a graph data. And as far as I'm concerned, for graph data, the best TSS that we had was under 0.8, but we have achieved more than 0.8, which is significant. So yeah, this is a robust application. Astrophysics can use this application to work with AI capabilities for solar flare prediction without having the knowledge of Python. When it comes to selecting hyperparameters, they have many options for each model. All of their data will be stored. They can access to the all of the tasks they have at any time. They can download the report again and again and remove their tags. For instance, imagine I don't like this task that I just created, this graph data. I will just click on this and click on delete, and I can simply delete it. I can manage all the sessions, all the tasks that I have here. And yeah, I will just now do logout. And this was an overview of all the features that we have on FlaPLeT.org. And again, you can go to the help page, and you can go to the this address here, and you can have access to the entire code of the backend and front end and Celery asynchronous task management, so that you can create your own AI-based web applications. For instance, you can create a web application such as ChatGPT by having your own front end and back end and using Celery as an asynchronous task management service. You can have access to all the information that you want here. You can watch the videos that I'm recording here. You can click on them. You will access to these videos. And yeah, thank you so much for your time and for paying attention to me. And thank you.